Hi everyone, very good evening and welcome to day 11 of Array and String Mastery series by Aarush coaching classes. So till now we have mastered binary search fundamentals and its applications. Today we are gonna tackle two advanced patterns that appear constantly in FAANG interviews, which are constraint optimization and the rate problems. Okay, these two things are majorly we are gonna focus upon because these are gonna be very important from your placement point of view in the FAANG interviews. So I would just say get ready to think like a logistic manager and a mathematical optimizer because that's what the next two problems we are going to discuss today is focused upon. So let's start with the day. So in our binary search journey, we have been able to cover these much things: the fundamentals of binary search and peak finding. It's what we do in our first day of binary search, and then next day we did the rotated arrays and woodcutter problem. So though fundamentals of binary search was more about understanding binary search and how it can be applied, and we saw that we can apply it on the sorted array. But after that, because with that particular logic you can implement multiple kind of searching, okay, multiple ways of searching using the binary search. But then later we got to understand about the few pattern based questions where binary search idea was getting implemented, where binary search was able to give us the optimized answer, but yet the input was not sorted completely. And one of them was the peak finding because the input was not completely sorted. In rotated array also it was sorted and then rotated, so the whole array as a one was not looking quite much sorted, but we were able to find some pattern and worked around it to apply the binary search. Then in the woodcutter problem, binary search was not being applied on the input itself. Here we saw that the binary search, we were applying it on a space, a new search space that we were able to find through our observation of the answer. So in order to call it accurately, we can say that on answers we were able to apply binary search to find the optimized answer. Means among all the possible answers, we were applying binary search to find the optimal answer. That's what it was about in the woodcutter question. Then today we are going to work around these two ideas: constraint optimization and the rate problem, in which we are gonna, for the very first thing, we are gonna discuss this pattern on capacity to ship packages question, where we need to find the minimum capacity given sequential constraints. Don't worry, I will show the whole question for better understanding. For now, just let's try to understand it very briefly. So it's a real world application in the logistics and resource scheduling. Next is gonna be the rate problem. In this pattern, we are gonna solve this Koko eating bananas. As I told you in the last session as well, most frequently asked question it is. Most of the time in most of the companies it is being asked in one way or other. Okay, not, they won't call it directly that solve the Koko eating bananas question, or they are not gonna give you the same problem statement. Instead, they will just modify it in the news story and then give you the question. But the course idea is gonna be the same. Okay, here we need to find the minimum rate given time constraints. Okay, find a minimum rate given time constraints. So I know that this much statement doesn't make much sense, but yeah, you can see that at least this is the pattern that I was talking about. So when we solve it, we will see more of it. Don't worry about it. And real world application, सिस्टम परफॉर्मेंस एंड रेट ऑप्टिमाइजेशन में इसका यूज़ हो रहा होता है. दिस काइंड ऑफ एल्गोरिथम इज वर्किंग. So why these pattern matters, as I told you, because the kind of interview you are preparing for, in those kind of interview, these kind of advanced questions, I mean advanced mastery based questions are asked more frequently. That's why I need to understand it and apply it properly. Okay, so you can see 70 plus percent times in the Amazon and 65% plus times in Google, handling sequential constraint and mathematical transformation. So yes, in the rate optimization we are going to use mathematical transformation. So let's go for the first question, very first question. capacity to ship packages within D days. Okay, so in some packages, I mean the name is suggesting itself, some packages would be given there and you need to ship them within D days. But let's deep dive into the problem statement to understand what are the other conditions. Okay, so problem says you are given an array of packages weights. Okay, package weights आपको दिए हुए हैं array के form में, given an array of package weights. Okay, and an integer d, एक integer d भी given है. Find the minimum ship capacity such that all packages can be shipped within d days. So what they basically try to say is, one ship is given there, you need to find a minimum capacity for the ship such that all packages which are given in the array can be shipped within d days. Okay, packages must be shipped in the given order. So this was the condition. Then there is one more condition, that the sequence or the order in which packages are given inside the array, they needs to be shipped in the same order. Okay, they needs to be shipped in the same order. So let's try to understand it in a better way. This is more like a logistic manager's challenge, correct? You handle the logistics, so you need to define it. The, you can say, optimized capacity for this particular problem statement. So as a ship manager, you have packages given with different weights. Okay, and you need to ship them in the same order, in the order in which they are given to you. You need to ship them in d days. Okay, and ship with certain capacity, and that capacity is going to be same for every day. I mean, first, if you have decided a certain capacity for your ship, you can't change it for the rest of the days. You need to keep it same for whole, for all d days, in order to ship all the packages in the same order. So that's why here comes the challenge. You need to find the smallest ship capacity, because it's a problem of optimization, correct? Smallest ship capacity that gets the job done in time. In time means within d days. Okay, let's have a look at an example. In the input, we are gonna be given an array having weights of the packages. Let's say one is given, so you can think of anything. One can be kilogram, one can be quintal, one can be tons also. So completely up to you. This is just symbolic way. Okay, so the packages weights is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total 10 packages are given and their weights are given here. They are asking what is the minimum capacity for the ship to ship all these packages within 5 days. Okay, output is 15. If you have capacity of 15, then you can ship it in 5 days. This is the optimal, means इससे कम तो हो नहीं सकता. If you have the capacity of 14, then you can't ship. So let's see how it is gonna work. Let's say day 1 I have capacity of 15. So first package, second package weight is 2, third package weight is 3, fourth is 4, fifth is 5. So 1 plus 2 plus 3 plus 4 plus 5 equals to 15. So on day 1 I can ship this much packages, है ना, D1. Okay, इतना हो गया. I can't ship more than that. Now for day 2, how many packages I can ship? I can go for 6 and 7. This will give me 13. But 6 plus 7, can I do 8 also? 6 plus 7 plus 8 would be what? 21. Correct? 21. But this 21 is greater than 15. That's why can't ship 8, है ना. 8 को same day पर नहीं put कर सकते. So if the ship is little empty, that would be okay, but the capacity can't be increased, and any item can't be shipped partially also. You can understand, correct? Because the order matters. अब 8 को day 2 and day 3 दोनों पे नहीं भेज सकते, either day 2 or day 3. So on day 2 you can ship only these two packages, 6 and 7. Now come to day 3. So day 3 you will start with 8. So 8 plus 9, how much would it be? 8 plus 9, 17. 17 is greater than 15, yes. So you can't ship 9. 9 ship नहीं हो सकता. So keep the ship empty and you can ship 8 only. So this would go on day 3. Okay, same for 9 also. If I add 10, it will become 19, which is greater than 15. So I can ship it only 9 on this day 4. Then for 10, it will be shipped on day 5. Okay, 10 हो जाएगा आपके डे 5 पे. So total, after this we don't have any more packages to deliver, and we have total 5 days in which we were able to ship it. Now let's try with 14. If you think say 15 is okay, but can we do it with capacity 15? Let's try with capacity 14. Correct? Let's see. On day 1, how many packages can we ship? Let's add 1 plus 2 plus 3 plus 4. How much will it become? 1 plus 2 3, 3 3 6, 4 10. Okay, if I do 5 it will become 15. Correct? Can 15, is 15 greater than 14? Yes. So 15, sorry, so 5 can't be added. So only day 1 पे कौन कौन जा सकता है? 1 2 3 and 4. On day 2, how much packages I can deliver? 5 plus 6. Okay, 5 plus 6 plus 7. Let's try. How much will it become? 5 plus 6 11 plus 7 18. 18 greater than 14 hai kya? Yes. So can I bring 7 also? No. On day 2 we can't. So 5 plus 6 would be 11. 11 is greater than 14? No. So we can ship this much. ये day 2 पे चला जाएगा. On day 3 how much we can ship? 7 plus 8. Okay, how much is it? 15. Is 15 greater than 14? Yes. So can I ship 8? नहीं, हम नहीं कर सकते. So I will ship 7 only on D3. D4 8 plus 9 17. Is it greater than 14? Yes. So how much I can ship? I can't ship 9 on this day. So on day 4 only 8 can be shipped. Day 5 I will be shipping 9. 9 is less than 14, correct. So next package weight is 10. Can I add 10 also? It will become 19. 19 is greater than 14. Yes. So can I ship 10? नहीं कर सकते, because the whole capacity is not that much to accommodate this. So we would have to go to day 6 to ship this package of 10. Is it greater than 14? No. तो ये ship हो सकता है. But it is day 6. How many days are given? But we were asked to ship in day 5 days only. Correct? 5 days only. So 14 पे possible नहीं है. Therefore capacity of 14 is not the answer. Okay, so I hope now you have got the idea of this question, what they're actually trying to say. Similarly, here is another example. Weights are given 3 2 2 4 1 4. 3 days are given and the correct capacity is 6, no less than that, because you need to get to the minimum capacity at least. Okay, so 6, 3 plus 2 5, and the 2 would be exceeding, so day 1. Okay, 2 plus 4 6, day 2. 1 plus 4 5, day 3. So in 3 days we are able to ship all the packages. So that's what this question is about. So you need to find the most optimal, or you can say the minimum number, minimum capacity for our ship to deliver all the packages in days equal to d, given as d. Okay, d equals to 5 here, d equals to 3 here. Okay, in the given days you need to ship it. So let's move further. What is the key insight for this particular problem? So fundamental insight would be the answer lies between where. Of course, if you look at the problem statement here, it is 15. Obviously the capacity would be more like, you can either say that any given to ship any given package on a day, minimum capacity would be, their conditions. To ship any given package in a day, minimum capacity would be equal to maximum weight, or you can say package with the maximum weight. package with maximum weight, because when you say any package, correct? So if capacity is 1, then this one package with the one weight can be shipped, but 2 can't be done. Similarly, if I have if I say कि इतनी minimum इतनी capacity है 7, so all the packages less than 7 can be delivered in any day, including 7, but more than that no. So if I keep 10 है ना, if I keep the capacity 10, so that any package on a day can be shipped, then this 10 would be the best answer, because what is the maximum package? 1 can be done, 2 can be done, 3 can be done, because all are less than 10 weight. For 10 also, if the capacity is 10, then this can be done. So first criteria is any package among the given package can be shipped in a day, है ना? तो वो उसकी मिनिमम कैपेसिटी होगी 10. मैक्सिमम कैपेसिटी क्या होगी? All packages can be shipped in a single day. अगर ऐसा करना हो तो how much would be the capacity? Then capacity is equals to, capacity कितनी हो जाएगी? In that case, if you want to ship all the packages, obviously then you need to find the sum of weights of all the packages, and that is gonna be the capacity. And here what it is, 1 plus 2 plus 3, 1 2 3 3 6 4 10 15 21 28, okay, 36, then 45 55. So it is 55 maximum, okay, is equals to 10. ये हो जाएगा हमारा minimum. So your search space of capacity lies between this and this. That's what we are trying to say on the next page. The answer lies between lower bound maximum weight ship heaviest package, which is 10, okay, and here it is gonna be 4, ठीक है, इस एग्जाम्पल के लिए. अपर बाउंड सम विथ शिप ऑल इन वन डे है ना, तो 55 था, एंड हियर इट इज 3 2 5 2 7 plus 4 11 plus 1 12 plus 4 16, okay. So 4 and 16 के बीच में लाई करेगा इसका आंसर, okay, which is 6 here. Now, so why binary search works here? Too small capacity takes more than d days increase the capacity, because when we have our search space है ना, ये search space हमें मिल गया, search कहाँ से कहाँ तक मिल गया, between 4 and 16 here, and for previous page between 10 and 55 we got our search space, yes or no? Search space मिल गया. So we can apply binary search. It is sorted also. Search space is already sorted. वो हमेशा 46 16 में सारे items sorted होंगे. We need to check for every weight, okay, according to the binary search logic, which weight is best for us to ship all the weights. Then you will say, sir, then how this question is different than the last question we solved in our previous class? The difference here is the order. Means 3 is given first, so 3 first delivers करना चाहिए, then 2, then another 2, then 4. In order to optimize, you can't say कि जो 6 wait करना ही है ना, तो 3 and 2 can be given equals to 5, then 1 को pick कर लेते, it will become 6 for day 1. No, you can't do this, because 1 is coming after 4, so it will go after 4 only, not here. So for this order criteria, you need to think a little, one new factor here to solve, okay, we will see. So monotonic property is given, as capacity increases day required decreases, because let's say if this is your capacity, let's say you were searching at 10 है ना, 10 capacity पे आप ढूंढ रहे थे, okay, and if it is possible to have 10 capacity and in the 3 days we can ship all the weights, that means where do we need to look further? 10 is feasible, we need to find minimum capacity, correct? So after 10 also it is feasible, so we'll discard this much, we'll move here है ना. लेफ्ट था, राइट था, 10 हमारा मिड था. So now we will move here. We'll discard this much. We'll move to 9. अब from 4 to 9 we'll try to search what is the best capacity or the minimum capacity. I mean by applying which we can ship all the packages in the desired day or the day 3. Okay, so that's what we are talking about. So search space lower bound maximum weight है हमारे पास, must fit heaviest package in one day. Upper bound sum of weights can ship all the weights at once, है ना, single day में हम लोग कर सकते हैं, तो sum of weight आ जाएगा maximum. Answer lies between maximum weight and sum of weights के बीच में. Okay, so that's what we are gonna do. So that was forever you can say search space. There is one more thing. Though you have picked your search space, like for this particular question the search space we picked was maximum weight was 4 and sum of all the weights was 16. So let's say if this was according to binary search logic, left this was right, then this would be the mid and mid would be what, 10 है, ठीक है. अब यहाँ 10 है. Now how are you gonna check that if I put my capacity as 10, then am I going to be able to ship all the packages within day or target days or not? So that's why we have a feasibility function which load packages sequentially until adding the next package would exceed capacity. Like here we have 6 as the capacity, है ना, output है. एक बार check करते हैं. First item if I pick 3, if I pick second item it will be 2, 5 हो गया. If I pick third item then 5 plus 2 will be 7. 7 is greater than 6, है ना. So therefore this 2 can't be shipped on day 1 on same day. Though we have some capacity left on our ship, but we can't put this package, third package 2 on our ship. We will be going with 2 packages on day 1 only. इतना ही ज़्यादा होगा. So this function is doing exactly that, calculating feasibility for you in how many days it is gonna take to ship all the packages with a per day capacity of 10 weight. Okay, so that's what it is doing. So weights would be passed, capacity would be passed. Capacity here is nothing but 10, ये 10 पास कर देंगे and ये D पास हो जाएगा यहाँ से. Okay, D would be passed. So at least एक दिन तो चाहेगा. So days needed, we are starting with day 1. Okay, current load because you have not added anything is 0. We are iterating over this weights array. इसे weights array पे iterate कर रहे हैं. If adding this package exceeds capacity, start new day. That's what our whole logic is about. Okay, in this feasibility function. So if current load को हम लोग अगर total current load plus means from the previous iteration, current load plus जो भी हम read कर रहे हैं from the weights array, the thing that we are reading from the weights array, if I add them and if they exceed my capacity, so I would have to increase the day, reset the current load because for the new day the current load would become 0, and then add it in the current load. Okay, so let's try and do this thing. So I will be here, first item 3a, so days needed would be dn first है, current load would be cn वो initially 0 था. Now first item पे I is equals to 0 पे my current load will become what, 0 plus 3 which is 3, है ना, because ये loop if statement में चलेगा नहीं because current load plus weight 0 plus 3 is greater than capacity. Capacity was 6 है ना, हमने 6 पिक कर रखा था, सॉरी हमने 10 पिक कर रखा था. We are working from 10. Okay, so ऐसा तो था नहीं. So that's why this will be running. Now I'm checking if days needed greater than capacity, greater than the target days, है ना, required days. उससे ऊपर तो हम डायरेक्टली रिटर्न फॉल्स कर देंगे फॉर अ पर्टिकुलर कैपेसिटी, अदरवाइज वी विल कीप कैलकुलेटिंग. सो इट इज़ नॉट हैपनिंग, सो आई विल कीप कैलकुलेटिंग. आई विल गो टू नेक्स्ट आइटम एंड आई विल चेक करंट लोड अभी कितना था, 3 था. सो 3 प्लस आइटम एट इंडेक्स 1 2 इक्वल्स टू 5. इज इट ग्रेटर देन माई कैपेसिटी 10? है क्या? No. So this won't be working and I will just add in the current load. So current load would be 5 हमने कर दिया, ठीक है. Again 5 greater than sorry, days needed which is 1, is it greater than 6? Sorry, 3. Days needed 3 is given. No, है ना. So what will I do? I will reiterate and go to next item in the weights array. I will pick 2 because this is the next. Now this time what I am going to do, again current load plus weight. So I is equals to 2 पे current load was 5 plus 2 equals to 7. Is it greater than 10? नहीं है ना. तो this won't work. Current load would get updated. CL equals to हमने 7 कर दिया directly. Is the days needed अभी भी हमारे पास 1 ही है and D is 3, so it is also not gonna work. Reiterate किया, I is equals to 3. I am at the fourth item, index 3. Okay, here again the item's weight is 4, so current load from the past was 7 plus 4, ये 11 हो गया. Is it greater than 10? Yes. So this time it will be true, so days needed plus हो जाएगा. So dn would be, last time it was 1, so plus 1, it will become 2 and current load would become 0 because I am changing the day. Now after this I am updating my current load with the current weight. So CL equals to plus equals to weight अभी क्या था 4, so plus 4 किया तो 4 आ गया because CL को हमने 0 कर दिया था. Okay, now again days needed greater than D, days needed 2 हो गया but it is not greater than 3. Okay, so what I will do, I will reiterate and go to the next item. Next item is 1, so I is equals to 4. Okay, so here what will happen, again current load plus weight. Current load क्या last time से 4 plus 1 equals to 5. Is it greater than capacity which is 10 right now? No. So I will increment the current weight. So CL would be 5. Is the days needed 2 greater than 3? No. So reiterate and I will see I is equals to 5 पे आ गया मैं अब. तो next item पे आ गया 4 पे. So it will again check current load plus weight. Current load 5 हो गया था plus 4 is equals to 9. Is it greater than 10? No, it is not. Capacity ज़्यादा अभी भी नहीं है, so current load को update कर देंगे. CL equals to 9. Days needed was 2. Is 2 greater than 3? No. So reiterate. I will reiterate and I will see that I have no more item to traverse. So I have come out of the for loop without hitting this false, so I will be returning true. Means having capacity of 10 is feasible to deliver all the packages under 3 days, है ना, क्योंकि हम 2 दिन में ही कर दिया हमने. क्या था, डेज हमारा 2 में ही कर दिया था हमने. So that means this function will return true, and if it is true means it is feasible. So what will I do according to the binary search logic? I will put my r at m minus 1, है ना, यहाँ पुट कर दूंगा मैं r को, which is 9. Okay, then here I will again start searching for the new capacity. So that's what this function is doing, and इसका टाइम कितना आएगा, ये big of n में हो रहा है. Okay, so this is the main function for this for the as part of this solution, because rest is binary search logic that you already know, you must have mastered it till now how to write it. So again, this is my feasibility function. If I can ship in the found capacity as a middle or not in the d days, given d days, this is my input array. Okay, now let's see the binary search logic. Binary search logic क्या बोलता है, same thing as the int max weight 0, int total weight 0. Okay, why I'm doing that I will show, है ना. हम लोग ये काम क्यों करते हैं, बिकॉज आपको लेफ्ट एंड राइट सर्च स्पेस का बाउंड्रीज तो निकालना है, करेक्ट. एंड इन दिस पर्टिकुलर प्रॉब्लम व्हाट वी सॉ ऑन प्रीवियस पेजेस, at the left we are putting what, maximum weight, and here right total weight. That's what is giving our search space. So maximum weight initially 0, total weight is 0. We are going to use a for loop to calculate it over the by traversing over this weights array. Okay, so we are calculating maximum weight and we are calculating total weight also. And here for this we will get what, for the maximum weight we will get 10 and total weight is 15. So search space is, this is my left and this is my right. Okay, सर्च स्पेस वुड बी 10 and 15. ठीक है, तो ऐसा हो जाएगा. Now after that we are marking as left and right the max weight and total weight, and answer initially I am putting total weight because सारा weight एक ही दिन में निकाल दो. ठीक है, all the packages will be shipped in single day. Initially I am putting it instead of taking as a maximum integer, I am putting it because for this particular problem it is not going to be greater than this, because at least one day you need to ship all the packages, and if you are going to do it, then total weight is going to be the capacity in which with which you can ship all the weights. Okay, by common sense, no major logic, you know. Now here is the same binary search logic written while left is less than equals to right. So we are finding the mid. So you can say for step 1 for, or you can say iteration 1 है ना, step की जैसे मैं iteration लिख देता हूँ. Okay, left is 10, right is 55. Okay, left and right, and mid is somewhere here. Mid is gonna be 32 if you divide it by 2. Okay, so mid मिल गया. Now I am gonna check using the feasibility function. Can ship weights array I am passing, mid as the capacity I am passing here. This is mid 32. Okay, as the current capacity I am passing, and d from the input, the needed days, you know, is what I am passing. So with 32 it is possible or not. With 32 the day needed would be 2. How? Let's see. So 1 plus 2 plus 3 6 4 10 5 15 6 21 7 28. Okay, 28 plus 8 would be 36, which is greater than 32. So ये day 1 में आ गया. ठीक, 9 8 17 10 27. This will be in day 2. 2 दिन में ही हो जा रहा है. If I have the capacity of 32, so 2 days are needed. So this function will return true to you कि feasible है. So if it is true, है ना, यहाँ पे अगर true return हो गया, means this capacity works and we need to try smaller capacity. Okay, so I will remember this answer first. In my answer variable as 32, I will take the action by discarding the right hand or you can second half of my search space after 32 and discard this. How discard? Mid equals to right minus 1, तो right हमारा 31 पे आ जाएगा. Okay, that's what is happening. That equals to 31. So that's why for the next iteration, if I go from here to here, next iteration, left is 10, right is 31, and now the new mid is gonna be here, which is 20. Okay, because it is combining 41, and if you take the floors and divide by 2 and take floors, it will 20. 20 how many days it is gonna take? कितना दिन लेगा? Let's calculate. So if I put 20 na, 1 plus 2 3 3 6 4 10 5 15 15 and plus 6 21, so only 15 only, correct? So 15 तक ये day 1 में चला जाएगा. Day 2 6 7 11, sorry 13 plus 8 would exceeding 20, so it would be day 2. 9 8 17 day 3, and last item would be for day 4. So total 4 days are gonna be taken for capacity 20. Yes, it is feasible because days required as 5, है ना, 4 is less than 5. So what will I do? Again this would be true, and I will be here. I will update the answer as 20, and the right would be mid minus 1 from here. So right would be 20 minus 1 19. हो गया. ठीक, let's come to next iteration. Next iteration, left 10, right 19, and mid would be 14. Okay, so here is my right at 19, mid is here at 14. Okay, mid is at 14, so this will you can calculate again. Okay, this will take 6 days. 6 is greater than 5, correct? So that's why it is not feasible. So this will return false. अब false तो मैं कहाँ जाऊँगा? I will go in the else part. Means I need to increase the capacity. 14 is less for us because we are not able to ship all the things, so increase the capacity. So left would be mid plus 1. So you can see in the next iteration, and answer is not going to change. वो last time भी 20 था, अभी भी 20 है. In the fourth iteration, left is 15, mid minus 1. sorry, mid plus 1. Okay, 14 था mid plus 1, 15 आ गया. So this left is here right now, this is 15. Okay, now new mid, 15 plus 19 divided by 2 would give you 17 with the floor. Okay, so mid में अगर 17 है तो how many days is it gonna take? It is gonna take 4 days. Again feasible है. So right would be updated this time, mid minus 1. So this time update, answer update भी हो जाएगा 17 पे. In the fifth iteration, my left is at 15, right is at 16 because mid minus 1, mid was 17 है ना, 16 पे आ गया. Mid is at 15. Mid जो 15 पे होगा will again use a feasibility function and we will get that 5 days में things are happening and 5 is equal to my this capacity, sorry the required days है ना, ये greater नहीं है, 5 greater than 5 नहीं है ना, तो क्या होगा, false नहीं जाएगा, ये true ही यहाँ से return हो जाएगा. ओके, ये ट्रू रिटर्न हो जाएगा. अगर ट्रू है तो अब मैं क्या करूँगा, आई विल फिजिबल है, अपडेट माई राइट एंड रिमेंबर द आंसर इज 15. ठीक, राइट वुड बी अपडेटेड एज मिड minus 1. So for next iteration, left is 15 and right is 15 minus 1, 14. Here you can see this is right crossing left. ऐसा नहीं होना चाहिए था. Therefore termination हो जाएगा. And answer after termination, my answer is to have stored value as 15. So return answers and 15 is the answer. Okay, 15 was the answer for this input. You can see 15 was the answer. So that's what it was all about. So now if I talk about the time complexity of this whole solution, we established on the last page ये big of n था because it's traversing over the whole weights array which is of length n है ना, ऐसा हो रहा था, worst case order of n. But for this how much time है ना, yeah, search space times search space पे चल रहा है, so log of length of search space is what gonna be the time. And what is the length of search space? Obviously total weight minus maximum weight है ना, which is total weight minus max weight. Okay, and log of this would be the time complexity of this particular function. Okay, so ultimately we can say that if the difference was the s, sum of weights, or can say total weight minus maximum weight is s, then log of s is for the binary search and outer the feasibility function was taking order of n, so the whole time complexity would be n log of s. Okay, feasibility check is taking order of n, binary search is taking order of log of s. And space complexity, we are not using any extra space, only constant space, that's why big of 1 only. Okay, this I don't think that I need to tell you, we have been discussing it since last many classes. I have just given it for you to remember how fast binary search becomes compared to the brute force approach. So it will be 50,000 times faster. Okay, optimization tips. Early return in feasibility check, that's what we have been doing. You can see that we didn't wait for everything to be checked till the end. Instead, whenever my day needed is greater than d, I am just returning false directly instead of checking it here and then returning, you know. So that's how I am optimizing it, using while loop instead of recursion, because recursion takes more memory on the stack. Okay, so this loop would be better at least here. I mean, there are trade-offs. I can't say every time that would be the best, but at least for this particular problem it is best. Okay, pre-compute bounds efficiently, that's what we did here. We pre-computed the bounds, that because अब ये क्या रहा ना, ये one time था, this was one time calculation. So हम ये कह सकते हैं कि total time कितना हो जाएगा फिर, because of this we can say that time complexity would be big of n log For computation, bounds computation एक बार किया था, this is a one time plus big O for the whole solution, order n for the feasibility check, and binary search का log of s. So n log of s, which one is greater? Obviously this one. So ultimately time complexity would become big O of n log of s only. So that's what it would be looking like. Okay, so pre-compute really helps, you don't need to do it repeatedly. So that was all about this particular problem. I hope you must have got it. Now let's move to the next problem, which is Koko eating bananas. So it is gonna be about the rate limitation, okay, hourly rates. So let's see what this problem actually says. Okay, Koko loves bananas. There are n piles. The ith pile has the pile size bananas. So in short, there is given an array. Every index represents a pile, and the item at that index represents the number of bananas in that pile. Okay, Koko can eat k bananas per hour. Next, they are saying that Koko, the monkey, can eat bananas, k bananas per hour. Okay, each hour she chews a pile and eats k bananas from it. हर घंटे पे at every hour she chooses a pile, एक pile choose करती है. This means that order of pile doesn't matter. Doesn't matter here. Okay, but that doesn't give you any comfort while solving this. Believe me. Okay, so she chooses a pile and eats k bananas from it. Now what I need to focus here is eats k bananas from it, and k bananas she eat per hour. Now look at this. If the pile has less than k bananas, she eat all of them and doesn't eat any more for that hour, because she eat k bananas per hour. ठीक है? If a pile have less banana, then she eats less banana, less than k bananas, then she eat and relax for the rest of the time in that hour. Okay, that's what this means. If the pile has less than k bananas, okay, she eats all of them and does not eat anymore that hour. Then in the next hour only she will move to next pile and try eating. Okay, so you need to find the minimum integer k. You need to find the value of k, means her hourly rate of eating bananas, such that she can eat all bananas within h hours. So h hours are given to you. A little similar to previous question, but finding the rate would be a little difficult here. Okay, especially when they have said that if the pile have less than k bananas, then she will wait for that hour, for the rest of the time in the hour. Once that hour is completed, then only she will move to the next banana. Okay, next pile. So mathematical challenge क्या है यहाँ पे? Coco needs to finish all bananas in h hours. H given hours are there. उसमें complete करना है. She can choose any pile each hour, but eats at most k bananas from it. कोई भी pile she can pick any pile, but she can eat at most k bananas from it in a particular hour. So you need to find the smallest k, means how many bananas she can eat per hour. She should eat per hour such that all the piles would be clear, or all the bananas would be eaten by her in h hour. Okay, let's see it through the example. In this particular example, you can see that the piles are 3 having, I mean the first pile have 3 bananas, second have 6, 7 and then 11. Okay, h is given 8 hours में सबको खत्म करना है. She needs to eat all of these in 8 hours. So what would the minimum number of bananas per hour she should be eating such that this would be satisfied? Answer is 4, so let's check it. Explanation क्या है? Of course, if she is gonna eat 4 bananas per hour, so let's say the items pile with bananas are given 6, 3, 6, 7 and 11. Okay, if I assume let k is equals to 4 है ना, 4 bananas per hour. Okay, so for this first pile or zeroth index piles, first, second, third index, okay, for this zeroth index pile items are 3, so 1 hour लगेंगे, yes or no, because 4 bananas per hour is what we have assumed as the answer. So she will eat 3 bananas and the rest, for the rest whatever time is left, है ना. Now she'll move to next pile, pile 1. How much time she is gonna take? See, 6 can be written as 4 plus 2. So 4 के लिए 1 hour. For this 2 also 1 hour. कितना हो गया? 2 hour. Now for if she moves to the third pile, items are 7, bananas are there. 7 को कैसे लिख सकते हैं? How many times 4 is 7? 4 plus 3. So for this 4 it will take 1 hour. For this 3 also it will take 1 hour. Total कितने हो गए? 2 hour. Okay. Next pile have 11, है ना. So how can I represent 11 as a sum of 4? 4 plus 4, 8 plus 3, correct, is equals to 11. So for the first 4 it will take 1 hour. For the second 4 bananas it will take 1 hour. For the last 3 bananas it will take 1 hour, though they are less but it will wait. So how many hours total? 3 hours. So how many total hours it is gonna take? 1 hour, 2 hour, 2 hour and 3 hour. Total hours is equals to 1 plus 2 plus 2 plus 3 is equals to 8, which is equal to h, है ना. इतना आ रहा है. So from here, from this whole breaking down of this calculation, you can see that every hour we need to eat 4 bananas. If there are less bananas then we will wait. If more, I will take additional hour. ठीक है. Okay. So how we can do this easily through the mathematics? So that mathematics is nothing but taking seal, है ना. Because if I divide 3 by 4 I will get 0 point something, correct. But I know that if the bananas are less than 4 then also it is gonna take 1 hour. Now if I take seal of 3 by 4 it will become 1, correct. 0 point something पहले आंसर आता, अब ये 1 बन जाएगा. Similarly if I take 4 by 4 means if there were 4 bananas it will give me 1, seal हो चाहे floor हो कुछ भी 1 मिलेगा. But if I have 5 bananas, if I take seal it will become 2 hour. So that's what the logic is applying here. Like for the 6 by 4, if I take seal it will take 2 hours. Okay, 1 point something आएगा तो वो seal होगा. If you take seal, if it is increased in fraction from 1 it will become 2. Okay, so that's what happens. That's how we can easily do this calculation using mathematical formula. What I showed you here can be represented mathematically, can be done using seal. Okay, so that's what we are gonna do to check. So now you are understanding about the feasibility function, yes or no. Whatever hourly rate I have picked, I will talk about the search space later, but let's talk about the feasibility function here, because through this whole logic that I have showed here, that's what we have been trying to achieve, to at least check कि if my hourly rate is 4 then is it possible for Koko to eat all the bananas in h hours or not. So this feasibility function is going to use the seal method to calculate this. Okay, now let's talk more about the search space, है ना. Let's see the pattern. So what is the insight about it? Answer lies between lower bound and upper bound. Lower bound क्या होगा? At least an hour Koko is gonna eat bananas. and what is the minimum number of bananas she can eat is 1, है ना. So that's the lower bound would be minimum number of banana she can eat in 1 hour. Okay, that's what is gonna happen. Upper bound, she can eat all bananas in 1 hour, maximum piles, है ना. I mean all bananas in a pile in 1 hour. ठीक है, ये कर सकते हैं हम लोग. So she is gonna eat all bananas in a pile in 1 hour. That's what. So what is here? 11 है. So that's why it will become 11 later. Okay. So that's what, I mean, that's how we are gonna decide the range, or you can say the search space. Why binary search works? Again, 2 slow rate small k, है ना, takes more than h hours increase rate. Let's say whatever rate you have fixed, if it is very small, then Koko is gonna take more hours than the required h hours, then you would have to increase the rate, है ना. And if you take value of k is very large, that the rate is too fast, so it will take fewer hours than h hours, so you need to decrease the rate. So that's how you can see that how binary search is being applied. The idea of binary search is getting perfectly fit here. So perfect rate would be if you get exact h hours or fewer but minimal, है ना, कि अब उससे कम क्या तो नहीं हो सकता h hours में. So that's what is gonna answer, similar to previous question. So mathematical transformation में क्या होगा, hours needed in the feasibility function we can use sum of ceil of pile size divided by k, okay, for all piles. That's what we are gonna do. So search space would be lower bound 1, upper bound to maximum piles, answer lies between 1 to max pile size. Okay, let's move forward. The feasibility function, that's what I showed you on the very first page of this particular problem. So I'm just gonna explain the method here, how it is used. So whole array is given to you, k is, I mean, you have let our rate is k, है ना, and h is your target कि h hours में ही ख़त्म करना है. So total hours would be 0 initially. You will traverse over this whole array having the pile size of bananas. Okay, now for every pile, है ना, you are doing a ceil division, pile plus k minus 1 divided by k. Okay, this is the formula, most efficient formula. You can try on your own also. Otherwise I have mentioned all the 3 methods, I mean most basic method also, you can go through it. And the reason is also written why I have done what I have done. Like method 1 is integer math efficient, ये डायरेक्ट हम लोग फॉर्मूला यूज़ कर सकते हैं, it is most efficient formula. Method 2 using math.ceil, you can use it but it will be little slower. Okay, conditional, so this much lines of code is what you need to include, है ना, to make it more simplified way to read. So among these 3 you can use any other formulas to calculate the ceil. Okay, so total hours plus equal to, for every pile we are gonna calculate how many hours it is gonna take and we will be adding it in the total hours, है ना. तो hours it is gonna take is gonna be ceil of pile divided by the k, है ना, and that is the, I mean, most optimized formula we are gonna use and add it in total hours. And for every pile, है ना, whenever we add we will check if total hours जो अब हमारे हैं वो greater than h है क्या, means required hour है क्या. Okay, if it is, then directly return false. If the total hour is greater than h, then directly return false, don't need to calculate any further. If it is not, means it is gonna be less than equal to h, so we will be returning true, है ना. ये comparison ही आपको true दे देगा. You could have written true directly also. So that's how it is gonna work. Next is complete implementation. So this is the feasibility function. This is gonna take big of n because it is gonna work on, I mean, traverse whole all the items in the given array. This is gonna be the binary search all part. I'm the main logic here. So we are gonna define our search space. Search space is gonna be one banana in an hour with maximum size of a pile 11 bananas in an hour, है ना, so that we can do things clearly. So now मैक्स पाइल है ना, वो हम लोग यहाँ फॉर लूप से निकाल रहे हैं. दिस फॉर लूप इज गोना टेक big O of n time. Okay, then we are gonna fit things for binary search. So left, ये 1 हो गया, ये लेफ्ट हो गया, ये राइट हो गया, ये हो गया 11. ओके, लेफ्ट एंड राइट हमने कर लिया. एंड एक आंसर वेरिएबल भी ले लिया जिसमें मैक्स पाइल ही हम लोग स्टोर कर रहे होंगे. ओके, विच इज गोना बी इनिशियली 11 only, है ना. आंसर equals to 11 initially. Now the whole binary search logic. Left is less than equals to right. Okay, great. Into mid equals to left plus right minus left divided by 2. We are finding mid. So initially left is 1, right is 11, mid would be 5. So here is my mid as 5. Okay, I'm gonna check using this visibility function. I'm gonna pass 5, okay, and see if it is visible or not. So with 5, let's see. Koko can eat 3 divided by 5. Seal would be 1 hour. 3 is gonna take 1 hour. For 6, it is gonna take 2 hours because 6 is greater than 5. 7 also 2 hours. 11, 2 times 5 would be 10, so 3 hours. Total would be 3 plus 2 5 plus 2 7 plus 1 8. 8 hours it is gonna take. So yes, it is feasible. What will I do? I will store it in my answer. Answer of 5 हो गया and take action right. Means it is feasible means I need to go to some smaller value of k, है ना. k अभी हमने mid को रखा था 5. So for that I need to discard this part and put my r here as 4. That equals to 4, mid minus 1. That's what has happened. Answer equals to mid and right equals to mid minus 1. Okay, after this reiterated left is less than equals to right. Yes, new mid, left is 1, right is 4, new mid would be 2. 4 plus 1 5 divided by 2 would be 2 for the mid. Okay, so if I take 2, I will do again the feasibility check. With the 2, what can I do? 3 divided by 2 seal, it will be 2 hours. 6 divided by 2 seal, it will be 3 hours. 7 divided by 2 and seal, 4 hours. 11 divided by 2 and seal, 6 hours. So 2 plus 3 5 plus 4 9 plus 6 15. 15 is greater than 8 hours जो given था हमें. That's why it is not feasible. Not feasible means यहाँ पर mid था ना at 2. Okay, not feasible means left would be kept here as a mid plus 1 3, है ना. लेफ्ट यहाँ से हटा दिया जाएगा. Answer would be same, no updation here. Third iteration, reiterate. So left is 3, right is 4, new mid is 3, है ना. अब वहाँ mid भी 3 पे ही आ गया यहाँ से हट के. Okay, now 3 divided by 3 seal 1, 6 divided by 3 seal 2, 7 divided by 3 seal 3, 11 divided by 3 seal would be 4. So it will ultimately become 10 hours. 10 hours is greater than 8 hours, so not feasible. Not feasible means move your left again as mid plus 1, है ना, and answer won't be updated. So left would be this time here, mid plus 1 would be 4. Okay, so in short, left and right both are on the same item, which is 4. Okay, same point. So left is 4, right is 4, mid will also be 4, है ना. यहाँ पे हम mid भी ले आते हैं. अब mid is 4. Let's check for the 4. 3 divided by 4 seal 1, 6 divided by 4 seal 2, 7 divided by 4 seal 2, 11 divided by 4 seal 3, 1 plus 2 3 plus 2 5 plus 3 8. Feasible है. So this time because the mid was 4, so answer would be updated as 4, and again right would be equals to mid plus 1. So right would be equals to mid plus 1, which is 5 now. So left is 4, right is mid minus 1 because I need to reduce, correct. So 3 पे आ जाएगा. Right is 3. Now they have crossed each other. This iteration they are not gonna work properly because this condition has become false, correct. 3 and 5. Left is 4, which is greater than right now, है ना. तो exit हो जाएगा. Once exiting, my answer have value 4, so it will return answer as 4. Okay, that's how it is gonna happen. So of course this is for the binary search logic. So time कितना होगा? big of log of search space. सर्च स्पेस क्या था, 1 to मैक्सिमम साइज ऑफ पाइल है ना, वो था हमारा. सो अगेन द टाइम कॉम्प्लेक्सिटी, एंड उसको अगर हम लोग m मान लेते हैं, लेट्स से m, सो टाइम कॉम्प्लेक्सिटी वुड बी बिग ऑफ n प्लस विच इज़ फॉर दिस, एंड ये फिजिबिलिटी फंक्शन यहाँ कॉल हो रहा है राइट, सो इट विल बी बिग ऑफ n log of m. ओके, बड़ा कौन है, log of m, सो बिग ऑफ n log of m would be the time complexity for this. Space complexity is constant, big of 1, we are not using any extra space other than the variables. So that was all for that particular question. Now let's have a quick comparison about the two. Time complexity for the capacity to ship was n log s. S was some weights minus maximum weight, and in Koko eating bananas n log m, where m was the maximum piles. Okay, 1 to maximum pile. Space was constant for both. Now patterns. Okay, so search space capacity to ship में max weight and some weights के बीच में था. Okay, Koko में 1 to max piles. Now for the feasibility, because this is the most important part. Okay, how you were able to do. So we were greedily sequential loading कर रहे थे हम लोग यहाँ पे. Greedy sequential loading was happening, and here mathematical ceiling division was there. So though we can say that in a way both questions were a little similar in terms कि search space आपको find हो गया, then you have to apply binary search. But then the feasibility and optimization was required, and that was very important and different in both questions. That's why having learn about these patterns becomes very important for you to solve more questions which are gonna be around these things. Okay, constraint, order preservation was there, the condition was there, and here time limit is there. So that's why here we were able to do the cell division, and here whenever the day was the capacity is increasing, you are changing the day. Okay, real world scenarios, logistic scheduling में काम आता है, it is in the rate optimization. Interviews we have already talked about, where it have been asked. Okay, as you can see the percentage on the very first page also we talked about it. In short, it is one of the most loved questions by the interviewers to ask to any interviewee. Okay, so you need to learn about these things. Now, advanced pattern recognition framework. How you can identify when to use binary search on answers, because binary search on the given input is completely okay. That is easy part, but at least figuring out that you need to apply it on the answer makes the difficulty bit more increased. But once you have figured out, then how to apply it or when to use it, correct? So problem characteristic क्या हो सकती है वहाँ पे, find minimum maximum such that y condition holds. This is an you can say identifier kind of pattern. So here optimization is what they're asking about, so it's completely related to today's problems that we have solved. Then sequential constraint, also to erase problem, capacity of to ship and greedy loading we used. Okay, mathematical transformation में we use ceiling division, Koko eating bananas questions में we solved it. Rate versus time trade off, इनवर्स रिलेशनशिप हमने कहाँ का देखा था, हमने कोको ईटिंग में देखा था एंड वुड कटर में देखा था कि व्हेन वी वर इंक्रीजिंग द रेट टाइम वाज डिक्रीजिंग, व्हेन वी वर डिक्रीजिंग द रेट टाइम वाज इंक्रीजिंग, है ना. सो देयर वाज दैट काइंड ऑफ रिलेशनशिप. सो दीज वर द थिंग्स कंबाइंडली मेड अस रियलाइज कि यहाँ पे बाइनरी सर्च लगाया जा सकता है. ओके, द मोनोटोनिसिटी वाज देयर. ओके, द यूनिवर्सल फ्रेमवर्क नाउ. Identify search space, lower bound, upper bound, so that you can apply binary search. Obviously, if you find lower bound, upper bound, this space is by default sorted, है कि नहीं है. 1 से start किया था 11 तक, so 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's how you can think about it. Define feasibility we can achieve. Okay, feasibility define का बहुत ज़्यादा important हो जाता है. Because you want to reuse it, so it is better to write it in a function, and this becomes the most important part of these kind of solutions. Applying binary search would be easy, but then deciding factor which direction to move would be helped by the feasibility factor. Okay, then binary search if feasible, because you want to optimize the answer, so go for smaller better minimization. If not feasible, try increasing the value. Okay, try larger maximization. So that's how things work. You can think in that way. रियल लाइफ एप्लीकेशंस एंड वेरिएशंस, लॉजिस्टिक्स में कंटेनर शिपिंग, डिलीवरी रेट ऑप्टिमाइजेशन फॉर द कोको. ओके. Tech, container capacity of ship question would be related to data processing batches. When we process data in batches, cocoa eating manners में API rate limiting, because API rate in itself shows that it is about time, correct? In a particular time frame, things are, I mean, API hitting is gonna happen, and how many times it can be hit, I mean, those kind of things can be, or those kind of problems can be discussed or come under this variety. Okay. In manufacturing, you can think of production line capacity, and here machine throughput, about time, cloud resource allocation, and here server performance tuning. So these are the kind of real life scenarios that you can relate to with these two questions that we have solved today. That's why I told you why, I mean, why this all the major companies ask this kind of question, because this is the kind of problem statements that you are gonna solve or work upon in those companies. And now you can see that these are how directly relatable. Okay. Popular interview variations. So constraint optimization में क्या होता है? Split array largest sum is kind of questions that you can try with a similar pattern. Minimum number of days to make bookest is another question. Divide chocolate is another question on the lead code you can try. Rate optimization, similar questions would be minimum speed to arrive on time. Find the smallest divisor given a threshold. Magnetic force between two balls. So these are the kind of questions you can try solving and relate it with the patterns that you have learned in these two questions today. Key takeaways. So we have achieved a conceptual mastery of binary search on answers for optimization problems. Okay. Earlier we were applying basic binary search on the input only. Constrained optimization with sequential processing. I mean, this was a condition for our very first question, shipping question. There we solved it. Mathematical transformation with ceiling division. In the second question we did it. Rate optimization with time constraint. ये भी second question में ही था. We did it. Now technical skills. We implemented order n log s capacity optimization. I mean, solution for the capacity optimization question. We implemented order n log m solution for rate optimization. Mastered greedy loading algorithm and became expert in ceiling division in the these both were part of the feasibility function. Okay, feasibility check function. Problem solving framework we have already talked about, so you can go through this. Okay, so levels of mastery. Okay, beginner, you were able to solve things using my guidance. You will become at intermediate level when you will solve these kind of questions that I showed you on previous page on your own also. Okay, implement these. Expert, when some unknown question is given to you which is not even on lead code also, which you have never seen, and you are able to recognize a pattern in those problems and able to solve it, then you will be called as the expert level, and this is where you need to reach. Okay, so that you won't be afraid of any more interviews and will be able to perform your best in any of the interviews. Okay, and as a homework you can solve these kind of problems on the from the lead code. These would be the basic foundation questions. Okay, and then which includes solving a question, dry run on all the provided examples and explain the solution and algorithm to your peers. Okay, whoever your friend is, whoever is there, you can teach to your juniors or anyone. It will make you or you can say give you better clarity around it. Applications, if you can try more questions, then these are the questions. Okay, mastery, these are the questions which are really gonna bug your mind in terms of thinking and making a relation. So I will say if you can solve these, it will make you reach to the mastery level. Okay, so all the question codes are given already for the lead code, so you can try all these questions. So that would be all for today, people. In the next session we will be starting with a string. Till now we have been working on the array only. From next session we will be starting on the strings and try to solve questions on a string with the, I mean, little variations. The algorithm we have learned, we will try to apply it and learn few more new algorithms as well. And after that gradually we will be moving towards recursion, backtracking and DP also. Okay, so please be prepared, and if you have liked our session till here, if it have been meaningful and helped you in terms of understanding the questions for preparations, so please like, share and subscribe, and let's meet in next session. Thank you everyone.